This lesson is 1.6, the law of sines, and our learning goal for this lesson is that students will understand how to use the law of sines to model and solve real-world problems. So before we can do that, we want to make sure that we understand what the law of sines is and how we can use it before we can talk about how to use it in an application. Okay, so in the last several sections that we talked about, we really focused on solving right triangles that had 90 degrees in them. But now we're going to look at how do we find the missing pieces or missing parts of oblique triangles. And an oblique triangle is just a triangle that has no right angles. You might want to put that in there if you're not familiar with the term. So we don't really have an opposite, adjacent, and hypotenuse because we don't even have a hypotenuse because we have no right angle. But that doesn't mean that we can't still use the trigonometry that we've talked about to solve for some of the missing parts. So if we do want to find some of these missing parts, there's a few things that we need to know. And if we want to solve a triangle, at the very least, we have to know at least one side and then any two other parts. So we have to have at least one side, and we could have two other sides, or we could have one side and two other angles, or we could have one side and another angle and another side. It really doesn't matter. So we have to have three things all together. But at least one of those things has to be the length of a side. And I just want to recall, I want you guys to remember that when we have a triangle set up like this, here, remember that where we have angle A, side A is opposite it. Where we have angle B, side B is opposite it, and angle C is opposite of side C. So don't forget about that because that's going to be really important to setting up and plugging in values into the law of sines. Okay? So let's talk about the different situations we might have when we're trying to solve an oblique triangle. So here we have just a regular old law of triangle, or excuse me, a regular old oblique triangle, just like we saw on the last screen. There's two different things that we can use to solve an oblique triangle. One of them is the law of sines, and one of them is the law of cosines. And depending on what information you've been given, you're going to choose which one of these to use. So I've got little triangles in here. You can kind of see them here. And I just want you to put those in your notes so that you can highlight the parts that we're interested in. And you know what? I might even make another triangle here because there's two different cases that are possible for this one. So we're just going to draw these little triangles in and highlight the parts. Okay, so for the first one, if I'm going to use the law of sines, one of the possibilities is if I have two angles and any side. So for example, if I knew angle A and I knew angle C, and let's say I knew side A, that's actually a format of what we call angle, angle, side. You might have studied that from geometry. So we have this angle, and then maybe we know, let's see, how am I going to do that? We have those two angles, and then we also have this side over here. That's an angle, angle, side setup. But it also works if I have what we call angle, side angle. So if I know two angles and then the side that's in between them, I can use the law of sines. Okay, so angle, angle, side, or angle, side, angle. Another place where I can use the law of sines is if I know two sides and then the angle opposite one of those. So here we know two sides. Let's use a different color. We'll use green. So let's say I knew the length of this side here, and I knew the length of that side there, and then I knew the angle that was opposite one of those sides. So that's kind of in the side angle setup. So any of these three cases, I'm going to be able to use the law of sines to solve. Now, if I haven't been given one of those three cases, it's going to be one of these last two. What if I have side, side, side? Well, that's kind of obvious. If I know all three sides of my triangle, if I have the values of all three sides, we're going to use the law of cosines. And I need to make a quick edit here. This one should be SAS. So make sure we get that correct in our notes, side, angle, side. So here if I know two sides and then the angle that is in between or that connects those two sides, so maybe these two sides and this angle here, angle B, then I'm going to use the law of cosines. So actually get this really neatly down in your notes because it's going to be really helpful when I just start throwing, pieces of triangles at you and I say, hey, solve the triangle, you're going to need to know, number one, do I use the law of sines or do I use the law of cosines? And then, of course, you're going to have to figure out how to set up the information. So what we're going to do next is set up a couple problems and use the law of sines so you can see how that process works. Okay, so let's talk about the law of sines for a second. If we have any oblique triangle, like we have here, right, non-right triangle, oh, but wait, this is a non-right triangle as well, and it's kind of a weird little triangle, right, because it's obtuse. Doesn't matter. We can still take the sine of any one of those angles. Actually, we can still take the cosine, too. The cosines are a little bit different, but we can take the sine of any one of those angles. Okay, and the relationship says that if I find the ratio of side A and divide it by the sine of angle A, that's going to be equal to the ratio of side B over the sine of angle B. And that's going to be equal to the ratio of side C divided by the sine of angle C. So if those ratios are all true, of course it's going to be true that the reciprocals are true as well. So I could flip the ratio if I wanted to solve for a missing angle instead of maybe a missing side, depending on what you're looking for. Being strategic about what variable you choose to have on top can just be a little bit helpful in the algebra. Okay, so this is our law of sines. It's on your bookmark. It's in your toolbox. Now we have it yet again, and it's easy to remember. Okay, so now let's go through our first example. So example 1 is an angle side setup. So we want to solve the triangle. The information you've been given is that the measure of angle C is 124, the measure of angle B is 26 degrees, and the side length B is 12 feet. And remember, we're going to put all that information over here in the left-hand column of our Cornell notes so that we can do this problem again later when we're studying, and we're going to have all the steps. Now again, I tried to get some steps over here to help guide you through this process when you're doing it on your own. The first thing is to draw a picture and label the parts. I mean, of course, that's the first thing. It's going to really help you in figuring out how to set up the problem. So let's look at that picture here. And we're going to make sure we label all the parts. Now I notice that C is 124 degrees, so I'm going to have an obtuse triangle here. And I know that B is 26 degrees, so I've kind of drawn that as a small little angle at the top. So C is 124, B is 26. We don't know the length of side C. We do know the length of side B. It's across from angle B, and it's 12 feet. And that's all the information that I've been given. So now we want to determine what type of triangle we have. Is it angle, angle, side, angle, side, angle? I already told you it's angle, angle, side. But I really want you to see that relationship. So angle, angle, side means we know two angles. We have angle B and angle C. And then we also know another side that's across from one of those known angles. It's not the side that's in between the two angles. If it were the side in between the two angles, it would be angle, side, angle. Anyway, now that we know it's angle, angle, side, we can figure out, oh, okay, for angle, angle, side, I'm going to use the law of sines. So we'll do that. Okay, so we answer this question, law of sines or law of cosines. It's going to be the law of sines because it was angle, angle, side. Now to use the law of sines, we want to find the angle and the side across from that angle that are known values. So in this particular case, that would be angle B, we know is 26 degrees, and then we know that side B is 12 feet. And that's really important because those are going to be, that's a whole ratio that we know the values of. Then we're going to use the other known value, which is C, to set up an equation and find the part that's across from C. So we know angle C, we're going to use that to find side C. And here's how that setup's going to look. We know that B over sine B is equal to C over sine C, right? So let's plug in the values. So that means that 12 divided by 26 is going to equal 12 divided by the sine of 26 is going to equal C divided by the sine of 24. Now if I want to solve both sides, if I want to solve the equation for C, I'm simply going to multiply both sides by the sine of 124. So that's going to cancel over here. And on the other side of the equation, if I simplify, I'm going to multiply across the top and bottom. So I'd have 12 times the sine of 124 divided by the sine of 26. and that would be equal to side C. Okay, so this is a time where you get your calculator out, you do a little do, and you'll get that side C is equal to 22.7. Let's see, in this case that would be feet. And that seems reasonable because it's the longest side in the triangle, so that's good. Now, we still have to find angle A and side A. So to find angle A, what we're going to do is add the angles that we know and subtract from 180 to find angle A, because we already knew two of them. We knew 126 and, or excuse me, 124 and 26. We add that together, we get 150. Subtract that from 180 and we get 30. So I'm going to take that and label my triangle with it as well. So there's angle A, it's 30 degrees. Now I know that, I can use the law of sines again to solve for side A. This time I'm going to do B over sine B is equal to A over sine A. Plug in the values that we know. 12 over the sine of 26 is equal to A over the sine of 30. And you could use C over sine C here. I just like B because it didn't have any decimal values in it, just a little easier to work out. We're going to solve for A by multiplying both sides by sine 30 over 1. That's going to clear that fraction for us. And again, these are going to divide to 1, so that's awesome. And then all we have to do is simplify. So let's see, wait a minute, I multiplied over here and it's not showing up. Let's make sure that shows up. There we go. Let's multiply by sine 30. So A is going to be equal to 12 times the sine of 30 divided by the sine of 26. And again, use your calculator to plug that in and get your value, and we'll find that A, side A, is equal to 13.7. So we have all the parts we want. We know that angle A is 30 degrees. We know that side C was 22.7 degrees. And now we've solved for side A was